Hello and welcome back. We're going to continue doing Mr. Wernau does your homework. Hey! Alright, so we're going to take a look at some antiderivatives using arc trigs. Now we have this integral right here where we have dx over the square root of 25 minus x squared. Now I'm always going to check u substitution. My u would be, of course, a 25 minus x squared, so my derivative would be negative 2x dx. And that doesn't cancel with anything, so I'm not going to use u substitution. So I'm thinking, this kind of looks like arc sine. So arc sine, my rule is arc sine u over a plus your constant. So this is a, this gives me, though that's a squared, so to get a we can just take the square root. And this is our u. Remember, the u will always be a function of x. So u is just going to be x. But remember, this is u substitution, so we do have to take the derivative. So du would be, of course, dx right there, and that tells me I'm not multiplying or dividing by anything. So we have our answer. We have u and we have a. So when we write our equation, we're going to get arc sine u, which is x, over 5 plus c1, and there's our answer. All right, let's take a look. There's a lot of space for just such a little problem, right? All right, so for number 12 here, this is from one of my worksheets. We're looking for the antiderivative of x plus 3 over 16 minus x squared. So again, I'm going to try u substitution. My u would be the 16 minus x squared, so my du is going to be negative 2x dx. And again, that's not going to cancel with anything on top, so I really can't use u substitution right now. However, I could use u substitution if I didn't have that 3. So what I'm going to do is I'm going to rewrite this integral as two separate integrals. To do that, I'm going to split that fraction. A really cool thing to do that we do in mathematics all the time. We split the fraction, and that's going to become the integral of x over the square root of 16 minus x squared dx plus 3, see I'm just splitting it up into two separate integrals. 1 over the square root of 16 minus x squared dx. Now for the first integral, this is our u substitution. So that was that 2x, it'll cancel. So that's my u substitution. Now I still have this extra integral over here, but again, if you notice, again, this is my arc sine function. Arc sine u over a. So let's deal with the u substitution first. Again, we're going to let u equal the 16 minus x squared. Du would be negative 2x dx. Dx becoming du over negative 2x. Using a little shortcut, we know the x's will cancel. We like it when that happens. And we're left with our new integral right now. And I'm going to rewrite that in blue. This becomes negative 1 over 2. Don't forget we have that constant here, that negative 1 over 2. And this is my u, bringing it up. We get u to the negative 1/2 du. And now we know how to integrate. So we get this negative 1/2 times the antiderivative of u to the negative 1/2 is 2u to the 1/2. I wrote a blank space here because I can just go and plug my u back in. This 16 minus x squared. Plus this 3, we're going to drag that down. And then we have our arc sine again. Remember, we know our a is going to be 4, and my favorite breakup line, u is x. Du is dx, so we're not multiplying or dividing by anything, and we have our arc sine. So we can write this as 3 arc sine u, which we said is x, over a, which is 4, plus c1. Now at the very end, we're going to enter c1. Of course, you can cancel those 2's if you feel like it, but there is our antiderivative. Very easy to do these. A lot of fun, actually, I think. All right, so let's take a look at another one here. This is a slightly more challenging one. Oh no, number 15. Again, so we're looking for the antiderivative of 2x plus 7 over x squared plus 4x plus 13. So I'm going to try my u substitution again. So I'm going to let u equal my du would be 2x plus 4. dx. This is interesting. See, unlike on the last one, where this 2x and this negative 2x doesn't match or cancel anything on the top, this 2x plus 4 looks almost looks like the numerator here, this 2x plus 7. So I am going to make this a 2x plus 7. Or, other way around, I'm going to make this 2x plus 7 equal to this 2x plus 4. And we can get that by subtracting 3. So I'm going to go this a little bit of a long way to go around this one. This becomes then 2x plus 7 minus 3 over the... now, because I minus 3, remember we have to fix this. So I'm going to add 3. This fixes the problem right there. Remember, we changed the equation by subtracting 3. By adding 3, we fix it. And this is still going to be all over x squared plus 4x plus 13 dx. Now, what that's going to leave me with is this 2x plus 4 plus 3 all over this x squared plus 4x plus 13 dx. Now, this 2x plus 4 is what I wanted because I know that can be U substitution. So, I'm going to, again, just like in the last one, we're going to split the integral. So we would get 2x plus 4 over x squared plus 4x plus 13 dx plus 3 over x squared plus 4x plus 13 dx. Over here, again, we have our U substitution. And over here, this is not a U substitution. So I'm thinking back to what we did the other day, and this has to be one of my arc trigs. And there's no square root, so I'm thinking this is arc tangent, U over A, and don't forget this 1 over A right there. So we are going to have to complete the square here. We'll talk about that in just a second. But let's go and take a look at our U substitution first. So if I do the U substitution, U is this x squared plus 4x plus 13. Du is 2x plus 4 dx. And that's going to give us dx is du over 2x plus 4. Those 2x plus 4's cancel. And what we're left with, I'm going to start over here, left with the antiderivative, 1 over u du. And we know that is just natural log of u, x squared plus 4x plus 13 plus, and now we're going to do our arc tangent rule. Now again, this is going to be plus 3. I'm just going to factor out that constant right there. But now let's work on our tangent. So when we complete the square, we're going to get x squared plus 4x plus 4. This is plus 13, so we have to minus 4, and we have to minus 4 because we're adding it here. And so that becomes x plus 2 squared plus 9. Now for arc tangent, don't forget arc tangent is, this is u squared plus a squared, right? So if I were to rewrite my integral here, plus 3, I'm going to factor that out. This becomes 1 over x plus 2 squared plus 9 dx. I know that a is 3 and u is x plus 2. Du is dx, that's what I want. So I have my u and I have my a. So when I plug it into my rule, we're going to get 1 over a, arc tangent u, which is x plus 2 over a, which is 3 plus c1. And there is our integral right there. Alright, so let's see how we prove these. Now, we talked about this in another video, so we're going to go ahead and prove arc sine of x, the derivative of arc sine of x, in case you forgot how to do this. So if we want to prove the derivative of arc sine of x, I think the problem actually says arc sine of u, keep it more generic. We don't know the derivative of arc sine, so if we say let y equal the arc sine of u, I know that the sine of u equals, other way around, that the sine of y equals u. And this I can graph, okay? So, ready? Here's the angle y. Remember, y is going to be my angle. My sine is the opposite, which is going to be u, over the hypotenuse, which is 1. And we get the square root of 1 minus u squared over here. So I want to find the derivative. So if I think of implicit derivatives, the derivative of sine would be cosine y dy du, because it's with respect to u, equals to 1. Now this says x, but just replace your x's with u. I probably should do that up here so we don't get as confused. Okay, there we go. So cosine, remember cosine is the adjacent over the hypotenuse. So cosine just becomes the square root of 1 minus u squared over 1 dy du equals to 1. Solving, dy du just becomes 1 over the square root of 1 minus u squared. And there is our rule right there. And you can do this with all of them. Ready? Let's try another one. Ready? What if I want to find the derivative of arctangent? Arctangent of x. Well, if I let y equal the arctangent of x, I know that the tangent of x equals y. Keep messing it up. I know that the tangent of y equals x. So if I look over here, my right triangle, there's my angle y. There's my angle y. Tangent is the opposite over the adjacent, so that's the square root of x squared plus 1. So let's see here, taking the derivative, this is secant squared y, dy dx equals 1. So let's find out what the secant is. Secant of x, in this case, remember secant is the adjacent, the hypotenuse over the adjacent, so it's the square root of x squared plus 1. Secant squared of x would just be x squared plus 1. So this becomes, so I can solve for dy dx by taking 1 divided by the secant squared, x squared plus 1. And you have your proof. Alright, so I hope you enjoy these videos. I'll see you guys later. Bye-bye.